Alright, so today we are supposed to talk about function pointers, right? So yesterday we've seen what structures are. We've seen why we need structures. We've also seen how to define them, how to initialize them, and also how to use them. So today we are going to talk about a concept in C which is also called the function pointers. So we all know what a function is. We also know what a pointer is. A pointer is simply a variable that holds the address of another variable, isn't it? But in the case of function pointers here, the pointer is not pointing to a variable. Instead, it's pointing to a function. Okay, that's also what a function pointer is. A function pointer is a pointer that is pointing to a function. Instead of a variable, that is in normal pointer case, the pointer points to a variable, right? But in this case, it is not pointing to a variable, it's pointing to a function. So, whatever you have stored on your machine, it has its own address, right? We've seen that how to find the address of a variable. Alright, so let me create a test file to explain this. So, okay, so if I do something like hash include, this is what we always do, stdio.h, and we do something like int main void. So this is a function. We all know this main here is a function, and we've seen that, right, when we're talking about functions. So this function here itself, it's stored in an address. It is stored in a memory. And this memory that this function is stored has its own address. Anything that is stored in the memory, we know that it has its own address. So if you have, let's say this is the memory now. Let's say this is the memory, right? And you have your function, your main function. So let's say this is where it is stored in the memory, this portion in the memory. And this portion here is going to contain the lines of code. We know that it's going to be converted to machine code first. So it's going to store this in the in the memory allocated for that function. And here, let's say it has the base address of 100. So it means that this 100 is the address for this whole block, isn't it? The base address of a memory block is the address of the block entirely, isn't it? So this main function now, what is the address of this main function? The address is 100. So I just want to show you that the main function also, or any function, is also stored in the memory, and you can get its address. Do you get it? So here, if I should now say printf, I want to print the address. I want to print the location where this main function is stored now. So I can use %p here, right? So here I need to pass the function name. What is the function name? It is called main, right? So if I do like this, it's going to print the address. Let's see. So gcc test.c-ot. Alright, so let's run it. So did you see that? I got the address. So this is where main is stored in your memory. Do you get it? So also, if I do something like this now, we know that whenever we are trying to get the address of a variable, we use the ampersand, isn't it, before that variable? Why is it that in the case of this function, I did not use the ampersand and I got the answer printed exactly? Let me use the ampersand in this case. Do you think I will get the same output? In the case of function, no matter how you do it, it's going to get the correct output for you. So in the case of function, it doesn't matter if you add the ampersand or if you remove it, because the function here what we are passing as argument to the printf is not a variable. In the case of variable, it will not work like this. You know that it will not work without the ampersand. You need to pass the ampersand. But in the case of function, anyhow you do it, it's going to work. So let's compile. So did you see that it worked? So if you like, consider the ampersand. If you like, don't consider the ampersand. Okay, so I just want to show you that functions also are stored in the memory, and they also have their own address. So now here, let's say I have a function that will find the sum of two numbers, right? It takes in argument int a, int b. So these are the arguments that the function takes. So how is this supposed, what is this function supposed to hold? Is simply return what? A plus b, isn't it? That's also what the function should do. So let me define the prototype here. So int, right, sum. I can define the prototype here, not necessarily inside my main.h. Yeah, I can do it here. So I would now say what should be the, I can just pass in just the data type int. It will still work even without passing the variable a and b. The what matters is just the data type. So here I have this function, right? I have this function that will what? That will calculate the sum of two numbers, right? So here in this case, how do we initialize or how do we declare a function pointer? I want to declare a function pointer that will point to this function directly. So anytime I want to point to this function, I will just call the pointer and then it will point me directly to this function, just like the way we normally do in case of variables, right? When we declare the pointer with the reference, isn't it, to get access to what that pointer is pointing to. So how do we declare a pointer to a function? I want to declare a pointer to this function here. What is the return type of this function? It is an int, right? So the first thing I need to pass to my function pointer is int. That is the return type of the function I'm pointing to. Do you get it? So the next thing we need to pass to the function pointer is, what is the name of my function pointer? What name do I want to give it? So I want to give my function pointer, since it is a pointer, I need to add this. And what is the name? I'm calling it add, for instance, since this is going to sum two numbers, right? So after this, what next? So the next thing we need to do is, what is the data type of the function you are pointing to? What is the data type of the parameters? Int, right? The data types are integer, isn't it? So I'll just pass in int, comma, int here. So this is simple declaration of a function pointer. You are pointing to sum, isn't it? So your function pointer should be declared in such a manner. The return type should be the same as that of the function. Then here you need to pass the function name, isn't it? Sorry, the function pointer name, the name you want to give your function pointer. And the next thing is what is the data type of the functions you are pointing to. If this function is pointing is taking what? Characters, then this has to be what? Characters. Do you get it? So now you've declared a function pointer. So assuming now I have something like this. Let's say I have another function, int sub, for subtraction. So this is also int, right? A, int b here, right? So this is supposed to take what? This is supposed to return what? Return a minus b, isn't it? And let's say I have another one for multiplication. So let's say int a, right? Int b, right? So this is supposed to return what? This is supposed to return a times b, isn't it? So I have these three functions here. Let me add their prototypes here. Sorry. So int, so int sub in this case, right? So it's taking also int and also another int, right? Then another one is for multiplication, which is also int, comma int. So if you notice something here, our function pointer here is pointing to which one? It's pointing to sum, right? But when you look at the remaining function, it is the same thing. The return type is also int, and also the parameters the function takes are also int. So it means that in this case, the function pointer here will be confused. The function pointer will not know which of this function you are pointing to, because all of these three functions here what have met the requirement for this, for this function pointer. So how do we do this? This is where you initialize. Do you get it? This is where you initialize. So in this case here, I can simply initialize this function pointer. So let's say I want the function pointer to point to sum. Do you get it? To point to sum. So I can simply say equals to sum here. So this is what equals to sum. So now let's try printing this. What if I say, before that, let me say result or let me declare the variable first. I need to declare result int result here. I want to store whatever the function pointer is returning. Do you get it? So here I can now say result is equals to what? What is the name of my function pointer? The name is add, isn't it? So I will now call it add, and then what? It's taking two parameters, integers, right? So I will now pass in what? Let's say 5, 2 here. Do you get it? So here I can now say printf here. So what should I print? I'm printing the result %d, right? So here I will pass in result. So let's see what will happen in this case. So let's compile. All right, so did you see that I got 7 printed because I called the sum function, isn't it? Add, because I initialized the pointer add to what? To sum. What if I change this to subtraction, to sub instead of sum? It's going to -2 from 5. Do you get it? Because I already have the function here, sub. So now I'm initializing my function pointer to point toward this sub function here. So let's try again. Let's see. So did you see that I got 5 minus 2, which is 3? Right? So if I change this to mul now, instead of sub, I'm still initializing the function pointer. If I change this to mul, what will happen? It will call this function here. Yeah, so and it will multiply them. So what will happen? What am I expected to get here? I'm expected to get 5 times 2, which is 10. Did you see that? So this is what? Simply how to initialize a function pointer. Okay, so now we've seen the different ways to we've seen how to declare the function pointer. We've also seen how to initialize the function pointer, right? So one of the things that we use function pointers for is what is called a callback function. Okay, it is what is called a callback function. What is a callback function? It's simply a function taking another function as its parameters. Do you get it? The function is going to take another function as parameter. Let me comment out this part now. This entire part in the main. Yeah. So now I don't have this. So let me try creating another pointer, another function. And this function is going to hold a callback function. Like I say, a callback function is simply a function that holds another function as its parameter. So I want to create another function here, which is going to be a callback function. So what I need to do here is I want that function to point to any of this, right? So the return type of this function is what? Is int, right? So and in this case, I'm calling my function, let's say output here, right? This is how a normal declaration. This is just a simple declaration of a function. So in this bracket for this function, I will now pass in what? A function pointer. Do you get it? I'm pointing to a function. It means that this function output is taking a function now as its parameter. So I'm pointing to one of these, either int, sub, or mul, anyone, right? I want my function pointer to point to any of this, depending on what I want the function to do. Am I interested in summing? Am I interested in subtraction or multiplication? Right? So here I will pass in, I will declare my function pointer here. So int, so what should be the name of my function pointer? Let me call it pt, for instance. Then here it will take in what? The parameters, which is what? Int, isn't it? And what? And another int. So this function here is taking what? A function as its parameter, because this is pointing to a function, isn't it? This is pointing to which function? One of these 3 functions, right? So and this function output is taking it as what? As its parameter. So this is a callback function now. Do you get it? So all I need to do now here is I can now say pt here. I need to initialize my pt now, right? So my pt is supposed to take what? 2 arguments, isn't it? So I will now say pt, and then let's say I pass in 4 and 5, for instance. So I'm passing 4 and 5 as the argument to output. So now I have this now, this output here, and this output is pointing to all of this tree, or let me say any of this tree. So how can I get this function here to what? To perform whatever function I want to perform? Is it summation? Is it subtraction? Is it multiplication? So I have declared it now, and I have defined the function pt. right? So I can come to my header file, inside my main.c. All I need to do here is I will now say output. Now I'm calling this function here, right? And don't forget, this function is pointing to summation, subtraction, or multiplication, isn't it? So inside this output, what is output taking? Output is taking a function as its parameter, isn't it? So since I called output here, I need to pass what? A function as its parameter. So let's say I want to sum this 4 and 5. So I will just pass in what? Sum here. I will just call the function here, because output is taking a function as parameter. Do you get it? So let me just create another variable to store it. So instead here I will now say I is equals to output and this. So I can now use printf. So I can now say printf is printing an integer, right? So percentage d, a new line, then I here. So I have this, right? So let's see what will happen. So gcc what output, did I not declare it? Okay, yeah, I did not declare the function prototype, so I have to put it here. So I declared the function prototype. Now let's test the program now. Okay, so compile again, gcc, yeah, so let's run it. So did you see that? Did you see that we got 9, isn't it? That is 5 plus 4, I think, right? That's what we added. Okay, so now what if I add, instead of passing sum as output here, if I should add sub here, what is this going to do? It's going to print 4 minus 5, which is what? A minus 1, right? So let's run this. Oops, not this. Did you see that we got a minus 1? So this is the use of a callback function. So if I should do something like, let's say instead of sub, let me just say mul here. So did you see that I got 20 now? So callback functions are important when you are trying to deal with a lot of cases. Let's say you have a program to deal with different cases, just like the switch case statement. Okay, that's where callback functions are used. Just like in this case, now we have 3 different cases to consider. So as you can see, callback function is the easiest way to solve this problem. We just create the callback function, and for any function we want to use, we just pass this as the parameter, isn't it? Here, as you can see, I have what? I have 3 functions, right? The sub, the sum, and the mul. So I can create an array to store them. Since all of these functions here are of the same type, I can create an array to store them. So how do I create an array of a function pointer? I can simply pass in the data type int, and here I will pass in what is the function pointer name. Let me call it pt, and then I will pass the size. What is the size? I'm having 3 functions to store inside, right? So I just pass in 3 as the size. Do you get it? I'll just pass in 3 as the size. That's all. So here I will just pass in the data type int. This is what? Creating an array of a function pointer. So here I can just initialize. So what do I want to store? I want to store sum, sub, and mul functions inside this pt, right? So I can just say sub, sum, and mul here. That's all. So I've created an array to store this. We are not going to go deep into this, but I believe when we begin example, we're going to see how to use arrays to store these function pointers. But this is how to declare a function pointer in an array format. All right, so let's see examples on function pointers. Okay, so make sure you go through the documentation here before you begin attempting the tasks. All right, so let's move on. So this task here says we should write a function that prints a name. But before that, when you look at this is the header file we're asked to create for this. So it is not main.h. Take note, it is function pointers.h. So let me give you an overview of mine here. So this is the function pointer. So this, the header file. This header file contains all the prototypes to the function, to the task on this particular project. Okay, so I don't want to be switching from one file to the main file always all the time. Okay, all right. So what I'm going to do first is this. It says we should write a function that prints a name, right? So let's open the file first. 0name.c. So vi paste. All right, so as you can see, I have my Betty documented, right? So let's understand the question. So it says we should write a function that prints a name, right? So, and as you can see, it takes in what? 2 parameters, right? It takes in 2 parameters. The first one is a pointer to a character called name, and the second parameter is a function pointer. And this function pointer takes in what? A character as argument, right? So all I need to do here is simply this. This function pointer here is pointing to a function that is responsible for printing characters. So when you look at this, the function pointer takes in what? Character as argument, a pointer to character, right? So it means f here will print whatever you pass to it as argument. So since I want to print a name, and this is the name I want to print, I will just pass it as argument to my f here. Okay, so the first thing I need to do is I need to check if name is not equals to null. That is the first parameter, if it is not equals to null, right? So if name is equals to null, right, or the function pointer itself is equals to null, which is f, right? So what should I return? If both of them are null, what should I return? I will simply just say return. Okay, I'll just return it, right? So else I will just say f, and then I will pass in name. So what I did here is simply I just pass in the variables name to what? To the function pointer f, right? So it means that this f here, this function pointer here, is going to print whatever it takes as argument. Okay, the function pointer takes in a pointer to a character. That's why I pass in a pointer to a character to it. So it's going to print f. Sorry, it's going to print name. Whatever the value of name here, it will be printed by this f. Okay, so that's all. So let's run Betty on this. So Betty 0 print name. Yeah, so as you can see, Betty is fine. So let's create the test file. So copy, and then so vi 0 main.c. all right, so pastes. All right, so let's save and exit. So let's copy the compilation command, copy, and then paste. All right, so as you can see, it has been compiled. So let's run the compiled file. So as you can see, we got hello, my name is Bob, and hello, my uppercase name is Bob Dylan. So we got the exact output here. Okay, so don't forget to add, commit, and push to a GitHub, and then you can run your checks. So now let's move on to the next task. So this task here says we should write a function that executes a function given as a parameter on each element of an array. Okay, so and this is the prototype, and where size is the size of the array and action is the pointer to the function you need to use. So what this is saying is that all you need to do is to create a function in which it will iterate over the entire element of this array, right? And for each element in this array, it will perform this action on it. Do you get it? For each iteration now, for each element inside this array, it will be passed as parameter to this action here, and then another function or another action will be performed on that particular element. Okay, so let's see how to do this. Let's open the file, vi. So sorry, vi this paste. All right, so as you can see, I have my Betty documented. All right, so the first thing we need to do is simply this. We are to write a function that executes a given function as parameter on each element of the array. So the first thing I need to do is I know that I'm going to loop over each element of this array, right? So I'm going to declare a variable for my looping, and I'm going to call it I. So, and the next thing I need to do is I need to check if the array is not null, right? And also the function here is also not null, right? So I will say if array is equals to null, or what is the function name action is equals to null, right? If one of this is equals to null, I will just return, right? I will just say return here. I can just return. Okay, so else what? Now I will loop, right? For I equals to 0, I will begin looping from the first element of the array, right? I is equals to 0. What should be the condition here? So this is the size of our array. Okay, this is the size of the array. So we know that we cannot loop to exceed the size of the array, right? So I less than size, isn't it? Then I plus plus. So this will loop over the entire element of the array. And for each iteration, we want to perform this action on each element. And as you can see, action takes in an integer parameter, right? Isn't it? It takes in an integer parameter. And our array as well takes in what? Integer. So all I'm going to do here is I will just call the action function. I will just say action. And then the parameter of action will be my array name and what? Index I. So what this means is for each iteration of I, go to what is in array at that index and pass it as argument to this action function. Do you get it? So this way I will get all the parameters of array passed to what this argument action, this function action, and it will perform a certain operation on it. Okay, that's simply what this function is asking us to do. Okay, so let's test the function. For that, let's run Betty. Alright, so don't forget I already have my prototype. Okay, so I have this. So the next thing I need to do is just copy the test file. Copy the test file. Yeah, so this is task 2, right? So I'll just say vi1 main.c. Isn't it? So I'll just paste. Alright, so let's compile now and let's test. So compilation command is the compilation command. So copy, paste. Okay, it says signed and unsigned integer. Okay, I'm trying to compare a signed value, an unsigned value with what? An int, unsigned int. So this has to be what? Unsigned int, right? So this size underscore t you're saying is just like saying, it's just saying that this is an unsigned integer. Okay, so I need to declare my I as an unsigned int since I'm comparing it with what? A variable that is also an unsigned int. Alright, so let's run Betty. Sorry, we've run Betty already, right? So let's compile. So as you can see, it has been compiled. So let's run the compiled file. So as you can see, we got the exact output here, right? So don't forget, add, commit, and push to your GitHub, and then you can run your checks. So now let's move on to the next task. So this task here says we should write a function that searches for an integer. Do you get it? It's going to search for an integer, and this is a function prototype where size is the number of elements in an array called array, and CMP is a pointer to the function to be used to compare values. So this is pointing to the function that we are going to use to compare the values. So int index returns the index of the first element for which the CMP function does not return 0. If no element matches, return -1. If size is less than or equals to 0, return -1. Okay, so let's open the file first. We'll explain what this function is asking us to do. This task is asking us to do as we begin writing the code. So open. So as you can see, I have my Betty documented as well. I'm doing all this things so that I will not be taking time documenting Betty and all this. I'm sure you by now you must have been familiar with all these things. So the first thing I need to do, I need to check if array is not equals to null, and also if the CMP is not equals to null. So I'll just say if array is equals to null, right? If it is equals to null, we want to return what? And also if my CMP is equals to null. If both are equals to null, what should I return? Let me just return a -1. I'll just say return -1. Okay, why am I returning minus? Because the pointer, the prototype here is returning an int. I cannot leave it without any value here, okay, since it's expecting what? An integer value, right? So the next thing is if size is less than or equals to 0, I'm also expected to return a -1. So I'll just say if size, right, is less than or equals to 0, right? So what should happen? I will return a -1, right? So the next thing I need to do here is I need to loop over each element of the array, right? We need to loop over each element of the array, and for each element in this array we need to pass it to this CMP function, isn't it? We need to pass it to this CMP function. This CMP function is responsible for checking, right? You just look at the CMP is a pointer to the function to be used to compare the values. So the CMP function will be used to compare the values. Do you get it? So for each iteration of array, we will pass it to CMP, right? So I need to declare a variable for my looping. So let me call it I. So I'm going to use it for the looping. So here I'll just say for I, I'm starting from index 0. So what should be the condition? I less than size, right? We cannot loop and exceed the size of the array. So I plus plus, right? So here inside this for loop now, I need to pass in what? Another condition here. So when that function finds a match, it's going to return a 1. If it doesn't find a match, it's going to return 0. So I can set a condition that if this CMP, since it does the same thing as well, it's used for comparison. If CMP at array index I, What this means is simply for each iteration of I, pass in the element at that index to CMP so that it will be compared, right? For each element here, is it equals to 1? If it is equals to 1, it means what? A match has been found, right? If it is equals to 1, a match has been found. So what should we return? We need to return the index in which the match is being found, right? So in this case, it is what? I. So if I is equals to 0, it will check what is in index 0 of I, and it will pass it, it will check what is in index 0 of array, and it will compare it. Is it equals to 1? Is it equals to what CMP is pointing to? If it is 1, then definitely it finds a match. So it will return the index of what? Of the character that the match is being found. Do you get it? So that's what this is going to do. That's how it will keep doing. It will keep doing until it finds a match. Do you get it? If it doesn't find a match, this is what will happen. We are just going to return a -1. That's what the question says. The question says if no element matches, return a -1. Okay, so let's run Betty to print. Okay, to int, right? Let's see. Okay, it says no description found for return value. So let me explain the return value. Okay, yes, it's supposed to be returned. So this is going to be return, or shall I say return index of the matched character or a -1, right? So that's what the function should return. So let's run Betty. So as you can see, Betty is fine now. So let's copy the test file. Copy. All right, this is task 2, right? So vi to main.c. All right, so paste. All right, so we have everything here. So let me add this. All right, so now let's compile the program and let's see the output. So copy and then paste. So it has been compiled. So let's run the compiled file. So as you can see, we got the value 212, isn't it? We got the exact value. Do you get it? So that's simply what we need to do here. That's simply what the question is asking us to do. Okay, so don't forget to add, commit, and push to GitHub, and then you can run your checks. So we're going to stop here. In the next video, we are going to continue from task 3 of this project. So thank you very much. Till we meet in our next session.